Welcome to episode 7 of the podcast, The Tech Lounge, discussing building the foundation for agentic AI at scale. Go ahead and pull up a stool, grab a drink. Today, we are doing a deep dive into something that is, frankly, driving enterprise IT completely crazy right now.
Yeah, cheers to that. It really is the biggest headache in tech right now.
Cheers. So, for you listening, our mission today is to just cut right through the hype. You know, everyone is talking about agentic AI.
Everyone.
Right, but almost nobody is actually pulling it off at scale. I mean, the research we're looking at has this shocking stat. Nearly 2/3 of enterprises have experimented with AI agents.
Yep, they're all trying it.
But fewer than 10% have actually scaled them to deliver real value. 10%.
It's wild. The ambition is definitely there.
Yeah.
You know, the budgets are getting approved left and right, but the execution is just hitting this massive wall.
Right.
And when you dig into why that 90% is failing, it's really interesting. 80% of those companies point to the exact same roadblock. And it is not the AI models themselves.
Really, it's not the AI.
No, the AI models from the big labs are, they're incredibly capable. The real culprit is data limitations. It's the data foundation and the legacy architecture sitting underneath those models.
So the foundation is the problem.
Exactly.
Yep.
I like to think of it like a car. If we want to understand how this works, we need to look at three things: the chassis, the fuel, and the powertrain of enterprise tech.
Okay, let's unpack this. Because before we fix that foundation, we kind of need to understand how heavy this new house is, right?
Oh.
Like, why are these AI agents breaking our current systems?
Yeah, that's a great question.
Because for the last couple of years, you know, we've all gotten pretty comfortable with generative AI.
Sure, the chatbots.
Right. We ask a chatbot to write an email, and it just writes the email. Or we ask for a meeting summary, and it spits out a paragraph. But agentic AI is fundamentally different. Generative AI waits for a prompt. Agentic AI, it makes its own prompts.
Yes, that is the core distinction. What's fascinating here is that you're moving from a system that just retrieves information to a system that actually reasons, coordinates, and executes unpredictable workflows autonomously.
So it's actually doing the work.
Right. If you give a standard generative AI a complex goal, it just gives you a really long text response detailing how a human could achieve the goal.
Oh, yeah. Here are 5 steps to do this.
Exactly. But if you give an agentic system that same complex goal, it just starts doing the work. It navigates the environment, even if the path isn't perfectly mapped out in advance.
Which sounds amazing on paper.
It does.
But I'm looking at the reality of enterprise IT, you know.
Right.
We are talking about legacy systems that were built 20, maybe 30 years ago.
Oh, easily 30 years ago for some of them.
And they were built for human beings, just politely submitting forms one at a time, waiting for the server to load. What happens when you drop an autonomous AI agent into that environment?
It's chaos.
Yeah.
Complete chaos.
I bet it's like dropping a Ferrari engine into a golf cart, you know? The cart is just going to shake apart.
That is the perfect analogy. And this is why the architectural shift is so crucial. Instead of a single AI trying to do everything at once, the future is multi-agent workflows.
Multi-agent, so a bunch of them.
Right. Think of it like a really caffeinated corporate project team. You have this orchestrator agent that acts like a project manager.
Oh, okay.
When a big task comes in, the orchestrator breaks it down into dozens of smaller subtasks, and then it assigns those to specialized task agents.
Oh, wow. So like one agent might be dedicated just to querying the customer database?
Exactly.
Okay.
And another agent is assigned to analyze the messy, unstructured text in a complaint email, while a third one is over there navigating the payment gateway to draft a refund.
And they're all doing this at the exact same time?
Simultaneously. Thousands of asynchronous API calls in a millisecond. That is why your golf cart shakes apart.
Huh.
The old legacy system gets basically unintentionally de-dansed by its own AI.
Right. The chassis simply cannot handle the torque. So if the problem is that our agent swarm is vibrating the legacy IT stack to pieces, how do we fix the chassis?
You have to modernize the architecture.
But wait, 76% of tech leaders actually know they need an open, secure, and flexible infrastructure. They know the golf cart is broken.
Yeah, I know it.
But fewer than a third have actually built those interoperability features. And honestly, I have to play devil's advocate here.
Do it.
Isn't telling a company to update their architecture, just, you know, consulting speak for spend $1 billion in 5 years replacing literally everything. Like, nobody has the appetite for a rip and replace right now.
I hear that pushback all the time.
Yeah.
But a rip and replace is actually the exact wrong approach. You don't bulldoze the corporate headquarters. You just upgrade the plumbing and the electrical so you can plug the new appliances in.
So how do you do that without replacing the old stuff?
Through encapsulation, you wrap those old, fragile legacy systems in a protective layer. We're seeing companies do this with container-based orchestration platforms, and specifically using standardized APIs like the Model Context Protocol, or MCP.
Okay, let's demystify MCP for a second, because that term kept coming up in the research as this huge breakthrough. How does it actually work in real life?
So think of MCP as this incredibly robust, universal API gateway that is specifically designed for AI.
Okay.
Historically, if you wanted an AI to talk to your proprietary database, a team of engineers had to write a bespoke integration and then maintain it and update it every single time the database changed.
Which is a nightmare.
A total nightmare.
Sure.
But MCP standardizes that connection. The AI agent speaks MCP, and the MCP server translates that request into whatever archaic, weird language your legacy system requires.
Oh, so it acts as a buffer?
A buffer and a translator, yes. Yep. So these smart agents can pull data from legacy systems seamlessly. The agent doesn't need to know how the old system works, and the old system doesn't get overwhelmed by a billion requests at once.
Okay, the mechanics of that make total sense. We wrap the fragile legacy systems in MCP bubble wrap, basically, so the chassis holds up.
Right.
But here's where it gets really interesting. A world-class chassis won't get you anywhere if you fill the tank with, like, watered-down fuel.
Very true.
And in the AI world, that fuel is continuous, high-quality data.
It is.
The problem is most companies have deeply fragmented data. It's raw. And raw data is just crude oil. You can't just pour a giant spreadsheet into an AI and expect it to run a business.
And that is exactly the crux of why 80% of companies are hitting a wall. They have mountains of data, but it sits in these isolated departmental silos. An AI agent might be able to read the data, but it doesn't actually understand what it means in the physical world of that business.
Right.
Because an LLM is really just a sophisticated autocomplete engine trained on the internet. It has no inherent understanding of your company's specific accounting rules or supply chain constraints.
I actually want to share this real-world disaster scenario from the research because it illustrates perfectly what happens when you let AI loose on raw data without giving it context.
Oh yeah, this is a great example.
So for you listening, imagine a company builds an autonomous inventory agent. Its job is to monitor stock levels and autonomously order raw materials when things run low.
How helpful, right?
Right, sounds great. So this agent pulls data from the finance software and it sees a column labeled units sold. Then it queries the logistics platform and sees a metric called volume shipped. Now, to a language model, those two phrases mean the exact same thing.
They are semantically identical in plain English.
Exactly. But in the reality of that specific business, they are totally different. Units sold includes a massive pre-order campaign for a product that isn't even going to be manufactured for 6 months,
Right.
while volume shipped is just what physically left the warehouse this morning. So the agent, thinking there's been this sudden massive depletion of physical inventory because the units sold number spiked.
It panics.
It panics. It autonomously executes millions of dollars in purchase orders to restock the warehouse, and because it operates at the speed of compute, those orders are finalized in milliseconds.
It is terrifying. And it's a very realistic scenario. This is exactly why you cannot scale agentic AI without building a semantic layer.
A semantic layer.
Yes, it's the translation engine that turns raw data into actual business knowledge. And the secret sauce powering that semantic layer is something called an ontology.
Okay, explain ontologies like I'm 5, because they seem to be the thing preventing the AI from bankrupting the company.
Fair enough. Think of an ontology as a highly detailed organizational chart. But instead of employees, it's for your data concepts.
Okay.
It explicitly maps out the relationships between business terms. So it teaches the AI the physical laws of your company. It tells the agent, hey, units sold has a dependency on fulfillment date, and it does not equal a physical stock reduction until the volume shipped flag is triggered.
Oh, wow. So it forces the AI to look at the data through your specific business rules instead of just guessing based on internet definitions.
Exactly. It turns rows and columns into a map of actual business logic.
Yeah.
But, spreadsheets and databases are really only half the battle.
Right. What about the messy stuff? The PDFs, the panicked Slack messages, the customer service call transcripts?
Right. Unstructured data. A true semantic layer has to ingest all of that too. So we use things like vector databases to convert those emails and PDFs into mathematical representations that the AI can actually search and understand.
Got it.
So if a multi-agent system is handling customer service, it can read a frustrated customer email, check the structured database for shipping delays, review the unstructured policy PDF for compensation tiers, and then synthesize all that context before it takes action.
Which immediately triggers a massive red flag for me. Oh, yeah, because if the semantic layer is doing its job perfectly, this autonomous agent swarm now has access to the ERP, the bank accounts, the complaint emails, the return policies. It can read an email, decide a customer is angry, and autonomously wire them a refund.
Yeah.
How do you put a leash on something that autonomous? If you have a fast car and volatile fuel, you need incredible brakes. Not to stop the car, but so you can safely drive fast. And that brings us to governance.
Which usually sounds like the most boring topic at the bar.
Oh, I know. It really does. But here, governance is actually the secret weapon.
It absolutely is. And this raises an important question. How do you trust a machine that thinks for itself?
Right.
You can't let AI operate in a black box. You have to embed governance into the architecture. Now, some people think governance just means having a human manager sit there and click approve on every single refund or purchase order.
But if you do that, you haven't scaled anything. You've just created the world's most expensive, highest maintenance intern.
Exactly. It defeats the whole purpose. So you have to operate governance at the speed of compute. You use an AI gateway.
An AI gateway?
Yeah, it sits between your multi-agent system and your enterprise software. It enforces usage policies dynamically. It manages fine-grained access control, meaning an agent only gets temporary, read-only access to the exact data fields it needs for that specific subtask, and nothing else.
Okay, that makes sense.
And it logs everything. Every API call, every piece of context the agent considered, it's all recorded in an immutable log.
But logging a disaster after it happens isn't enough, right? We need to prevent the disaster. And the mechanism for prevention that I found absolutely fascinating in the research is the concept of guardrail agents.
Yes.
We are literally using AI to police AI.
It is an antagonistic setup by design, and it is brilliant. You have your execution agents, let's say a marketing agent, tasked with drafting social media posts and buying ad space based on current trends. But right next to it, operating in parallel, you deploy a guardrail agent.
Yeah.
And this guardrail agent has one job: audit the marketing agent in real time.
So before the marketing campaign goes live, the guardrail agent intercepts it.
Exactly. It scans the text for brand misrepresentation. It cross-references the claims against the product ontology to make sure the marketing agent isn't, hallucinating a feature that doesn't exist.
Wow.
And it checks the ad spend against the gateway's budget limits. And the guardrail agent detects a high probability violation. It severs the API connection and routes the workflow to a human review queue.
That is wild, but it makes sense. I mean, it's the only way to scale security. A human compliance team could never review thousands of agentic decisions a minute. Guardrail agents can.
Right. They operate within a strict control function, making sure the entire swarm stays compliant.
Okay, so let's look at the whole vehicle. We have wrapped our fragile legacy systems in MCP so the chassis doesn't shake apart. We've built a semantic layer using ontologies to refine raw data into high-octane fuel. And we've installed an AI gateway with guardrail agents to act as the brakes.
That's the foundation.
So what does this all mean? How does this actually change the day-to-day for you, the person listening to this? How do humans and agents drive the business forward together?
Well, this is the powertrain. The synergy between human strategy and AI execution at scale. And honestly, it requires a massive shift. 64% of executives say people in multi-agent systems must work in tandem.
Right.
We are moving from a world where you execute tasks to a world where you supervise and orchestrate digital employees.
Let's ground this in reality, because there was a massive case study in the research from the aerospace and defense sector.
Oh, that was a phenomenal example.
This is an industry with zero tolerance for error, obviously, and they were completely paralyzed by data silos. The engineers were dealing with 46 disparate data systems.
46. Just think about the friction of that. You're trying to engineer a complex aerospace component, and you have to reconcile manufacturing tolerances across 46 different databases, logins, and BI tools before you can even begin your actual work.
It's just a massive bottleneck, so how did they solve it?
Well, they didn't just buy a shiny new AI tool and drop it on top of the mess. They spent the time and capital to build the foundation we've been discussing. They unified their data layer, implemented those ontologies, and established a secure, governed environment. They called it an AI factory.
An AI factory, I like that.
By fixing the plumbing, they reduced their total number of tools by 50%.
Wow, 50% reduction.
Yeah, but the real ROI was the scale it unlocked. Because the data was contextualized and the guardrails were firmly embedded in the network, they could safely empower 10,000 engineers to rapidly build, iterate, and deploy their own AI agents.
That is the turning point right there. 10,000 non-software engineers given the ability to agentify their own workflows. They aren't submitting an IT ticket and waiting 6 months for a script.
No, they're doing it themselves.
They're building their own task agents to handle the mundane data reconciliation, which frees the human engineers to focus entirely on judgment and strategy.
And it forces a completely new management paradigm, which is fascinating. We are now seeing organizations assign actual performance metrics, KPIs, to individual AI agents.
Which is nuts. I mean, 45% of organizations are doing this, treating them like digital employees. But I really struggle with the implementation of this.
So.
Well, if I'm a department manager, am I actually supposed to write a quarterly performance review for a software algorithm? Like, if my supply chain agent misses its KPI for reducing freight costs, what is the actual management lever I pull? I can't exactly put an AI on a performance improvement plan.
Huh? No, you can't put it on a PIP. You don't manage its motivation, you manage its environment.
Oh, okay.
You measure the agent's accuracy, its decision speed, its cost per query. And if it begins to fail those KPIs, you audit its reasoning log through the AI gateway. You find exactly where it made a poor decision. And then you pull the levers available to you. You adjust its semantic context by updating the ontology. You refine its prompt, or you tighten its access controls. You are basically managing a hybrid workforce of carbon and silicon.
Right.
You hold the agent accountable to business targets, just like a human team member, but you optimize it through data governance.
That is a completely different way to manage a team. All right, well, let's bring this all back to the bar, finish our drinks, and look at the big picture.
Let's do it.
For you listening, if you are looking around your office and the AI feels like a glorified search engine that hallucinates half the time, it is because your data foundation is cracked. You cannot scale agentic AI by dropping it into a fragile, siloed environment. You need the interoperable chassis, you need the semantic fuel, and you need that governed powertrain.
Absolutely. And if we connect this to the bigger picture, there's one more stat from the research that just blew me away. 72% of leaders expect agentic AI to enable entirely new business models and industry structures.
Entirely new models.
Right. We spent this whole conversation talking about how agents will automate the internal processes we already do today. But the true disruptive power of a strong multi-agent foundation is what allows you to invent outward.
Right. It's not just doing the old things 10% faster. It is deploying a fleet of outward-facing agents. Imagine your competitor builds a swarm of highly governed sales agents.
Oh, man.
And they don't just draft emails. They actively negotiate contracts at the speed of compute with the autonomous purchasing agents of their clients. They bypass human bottlenecks entirely.
That is the reality approaching us. The companies that are stuck trying to figure out why their generative chatbot keeps crashing their legacy databases, they are going to be left far behind by the companies orchestrating thousands of autonomous digital employees to invent completely new services.
It's a totally different way of thinking about enterprise architecture. The heavy lifting isn't the AI. The heavy lifting is the plumbing underneath it. What happens to your specific industry when your competitors are using autonomous agents to invent completely new services that humans couldn't manage alone? That is a wild thought to leave you with. Keep questioning the tech around you because the foundation you build today dictates the future you can invent tomorrow. Thanks for hanging out with us. We'll catch you on the next deep dive.